So where does solar fit into the energy mix? Solar energy exists in two forms that we can use for electrical conversion. One is direct solar to thermal, creating a superheated fluid, which can be used to make steam and turn a turbine. And there are certain places on the Earth that can use this technology and resource, but they need a lot of direct, cloud-free sunlight for many hours per day throughout the year. The other way solar energy can be used is the direct conversion of solar energy to electricity using photovoltaics. This is the subject of the course and the specialization. Solar energy is the only major electrical generation process that does not use a turbine. So let's look a little closer at how solar photovoltaics function by looking at the solar resource, or what we think of as the energy of the sun. The sun is the largest fusion reactor in our solar system and emits all forms of electromagnetic radiation, from X-rays through TV and radio waves. It turns out that the largest region of high-energy electromagnetic spectral energy exists in the visible region, what we see as blue through red. As we look at using solar energy as a resource, we're going to pair our solar photovoltaics to function with the energy that's available from the sun. So how much energy is available from the sun? Well, if we look at the different forms of energy in this diagram, you can see the sun produces the largest amount of energy over 1 year compared to all the other forms of energy combined, both renewable and non-renewable. As we look at the solar resource, the size stays constant year after year, whereas those traditional energy forms like fossil and nuclear begin to go down as we use those reserves. To put this into perspective, let's look at how the human population changes. It's ever increasing, and our energy consumption is also increasing. Consider how we might be able to solve this problem when non-renewable energy sources decrease year after year. Thus, solar might be one way to support our energy needs because it's plentiful and globally available. Now that we know that the sun is the largest energy source that we have available, let's look at how we can use it as a resource to deliver the electricity that we need to meet our demands. Photovoltaics are the tool we're going to use to convert sunlight into electricity. The word photovoltaic comes from the Greek word photo, meaning light, and volta, named after Alessandro Volta, who was a pioneer in electrical energy and invented the electrical battery. So the word photovoltaic means light to electricity. The photovoltaic effect was first observed by Alexander Becquerel in 1839, when he found that when light hit a piece of metal, electrons would begin to flow, thus making electricity. The concept was largely ignored and not well understood until the 1950s, when Bell Labs rediscovered the photovoltaic effect and invented the photovoltaic cell, or solar cell. That became part of the space race and provided electricity in space as well as on Earth for off-grid situations. Modern photovoltaic manufacturing came around the 1970s, where it was the go-to source for remote electricity needs, but it still had limited use. The technology then matured when other technologies like inverters and standardized components were invented, which enabled photovoltaics to be compatible with our current electrical grid system. Photovoltaics are considered a mature technology with broad adoption across the world. Large investments are being made across the globe to electrify both remote and rural areas, as well as support the increasing electrical needs of modern society. Costs continue to decrease as the efficiency in materials and manufacturing continues to increase. In this broad overview, you should now be able to identify the primary sources of energy conversions and differentiate between renewable and non-renewable energy forms. You should also be able to describe the relative size of the solar resource compared to traditional energy sources. Finally, you should now be able to briefly describe the history, invention, and overall investments in photovoltaics.